Hey everybody, it's been a while since you've maybe seen me. I know we've been doing Mr. Clendenin's videos. I've been making the activities, but good to see you guys again. We're gonna change things up a tad bit, how we're gonna be kind of doing our notes and homework. They're gonna be a lot shorter. So you guys, what I want you to do is please take out a sheet of paper. You are going to put the same title that is on the board, 4-6, solving tricky equations, day number 1. Then what you're gonna do is you're gonna write down all the problems with me. I'll probably put the homework at the end of our videos as well, and we'll just do them. We're not gonna do guided notes as sections. We're just gonna kind of do concepts to help you kind of move along and learn a little bit of the stuff that we would have learned if we were here in school. So miss you guys, but let's go ahead and get into the videos, the problems, and see if it kind of makes sense. All right, you guys, today we're only gonna be doing 3 examples together in class. So number 1, you're gonna write down 5 touching means times tangent of x plus 7 equals 12. So what we're gonna do is we're gonna be solving the equation using all the same skills that we've done before, but now it's just gonna have a trig function in it. So in order to get this x by itself, I have to remove everything on its side. Well, the first thing I'll do is I'll minus 7 from each side. When we do that, I will have 5 times tangent of x equals 5. Now, the next thing you will do is divide both sides by 5, and we'll have tangent of x is equal to 1. Now, here is where you do got to make sure you remember how to solve for missing angles in your trig class, in your geometry class, or what we did earlier this year is we'll take the inverse tangent of both sides. I'm actually going to show that work. Because before we had what was called a restricted answer. Well, now we're going to give the answer in between 0 degrees and 360 degrees. So on your homework, I want you to do that as well. Give your answer, or all the answers, from 0 degrees to 360 degrees. So when I type this in my calculator, I realize I should have been able to do it without a calculator, because 1 is 1 over 1. And that's the opposite side, that's the adjacent side, so it was actually a 45-degree angle. Now if you type it in your calculator, you'll get 45 degrees. But once you see something special, or that's the family of 30, 45, or 60, or you should have been like, oh, I could have done that without a calculator. So at first, you might think it's only 45 degrees and you box your answer, but that's incorrect. Because if we remember our little chart of all students take classes, we need to figure out possibly if there are more angles that would work for this. And the way I think about it is tangent of x can equal positive 1. So this 45 degrees is just the family, but tangent is positive in the first quadrant. 45 degrees would fall in that quadrant. But tangent is also positive in the third quadrant. So I need a 45-degree family member in that quadrant. So I kind of draw it out before I pick them, before I state them. So I kind of put the angles that would work for this, and I put them in the 45 family. So 45 degrees up is just 45 degrees, and that is one solution. And 45 degrees after 180 is 225 degrees, which is our other solution. So please make sure you do not just box the answer that you get in a calculator, but now we have to think about all of the angles in the first rotation, 0 degrees to 360 degrees, that would satisfy our equation. Now what you can do is you can go ahead and you can plug these back in. You could take 45 degrees, plug it in there, do all that math, and it will equal 12. But you could also plug in 225 degrees, because tangent of 225 degrees is 1. 5 times 1 is 5, plus 7 is 12, and it works out. So we might be getting more than one solution now. All right, you guys, let's see if the second example will kind of make sense. And please remember, you guys can pause, re-watch all this stuff to where then it will click more. So it might not just make sense the first time you hear it. Number 2, we're going to have cosine of x plus 4 is equal to 3 cosine of x plus 5. So same thing here. It's really the same as equations from our Algebra 1 days or earlier on this year. We just got to get x by itself. But if I have a trig function over here and over here, that's okay. Just like I could have had variables on both sides of the equation. So I'm going to kind of just do the double move here. I'm going to minus cosine of x on the left side and the right side. And I'm going to minus 5 on the right side and the left side to get my variable stuff, which does have a trig function in there, on one side and my regular numbers on the other side. So these cancel. This leaves me with -1 equals 3 cosine of x. Take away 1 cosine of x is 2 cosine of x, and these cancel. So now I'll divide both sides by 2, and I'll have -1/2 is equal to cosine of x. All right, to get x by itself, you will inverse cosine both sides. And before you plug it in your calculator, I would suggest that you think about, should I know this one or not? When you're doing the inverse cosine, or you can look back right up here, this would be the adjacent side, and this would be the hypotenuse side. Well, do we know out of the 30, 45, or 60 family, or quadrantals, where an adjacent side is 1 and the hypotenuse is 2? And we do. It's actually the 60-degree reference angle. So if you know your triangles well enough, there's 60 degrees. The adjacent side, which would be across from 30, by the way, is 1. That's rad 3, and that's 2. Sorry, that's supposed to be a right angle, pretty ugly triangle. But 60 degrees has an adjacent side of 1, has a hypotenuse of 2. So whenever I type this in my calculator, I'm not going to get 60 degrees though. I'm going to get 120 degrees equals x. But that is not the only solution. We really got to understand families of angles having the same reference angle. But now when I draw out 120 degrees, it might make a little bit more sense. If I draw 120 degrees, I travel, and I end up right here. Well, the reference angle in between 120 degrees and, that's an ugly 0, 120 degrees and 180 is 60 degrees. So the family came from my brain. The calculator will give me the actual angle sometimes. But again, I need to understand all students take classes. Please remember, this is when things are positive. So cosine is actually positive there and there. So if cosine is positive in the first and fourth quadrant, it means that it would be negative in the second and third quadrant, and the calculator actually gave me the second quadrant angle. It already gave me the 120 degrees. Now I just need to go down to the third quadrant, put his family member with a reference angle of 60 degrees. 180 plus 60 is 240 degrees is my other solution. So again, please make sure that you really understand about the families of angles. The fact that having the same reference angle can give you the same answer. Now, you can take 120 degrees, plug it into both x's in the original equation, and it will equal each other in a calculator. Same thing with 240 degrees. All right, we're going to do one more example today, you guys. And you will have 3 homework problems. So we're trying to keep things a little bit shorter for you, a little more manageable. And here is number 3. Now 3 is going to be a little bit tricky for you guys because we're going to see new notation. It's 3 times sine squared of x plus 5 sine of x plus 2 equals 0. So whenever we look at this problem, you guys, this is a new notation. Whenever the squared, it just means that you have basically sine of x times sine of x. It's very similar to normal powers, but when you see sine squared of x, that is sine of x times sine of x. All it is again a power, which means repeated multiplication. They just put it right after the sign. You know, the other way you could look at it is, it really is sine of x squared, but they wanted to take away the parentheses, so it's just a little shorthand notation. Well, whenever I look at this problem, to me, this looks like an MA bottoms up problem. Because I have 3, I'm going to say sine of x is a right now, is like a squared plus 5 times sine of x is a plus 2 is equal to 0. So when I see a problem that might mimic something in Algebra 1, I use the same math that I would use in Algebra 1, and this right here, you guys, is Mrs. Tom's method, MA bottoms up. Depends on which teacher you had is what they call it. I call it MA bottoms up. So we're going to have to factor that just like we would have this red equation. So I'll kind of keep that equation up there just to help out, but I do my MA work. So I go MA. My multiply number, front times back, is 6. My middle number is my add number, and I got to think about what 2 numbers are special that multiply to 6 and add to 5, which is 2 and 3. So I set up 2 parentheses, still equals 0. Now normally I'd put a there and a there if I was with this red equation, but I'm not. I have to make up the sine squared of x. So I start with sine of x times sine of x. Those two make sine squared of x, right up there. But now I need to put my special numbers. I put positive 2 and positive 3. But remember, when you're doing bottoms up method, you're not done. You have to divide by the front number 3. So divide by 3, divide by 3. That gives me quantity. Oh, sorry, this is bottoms up, so since it's a fraction, bring it up. This gives me quantity 3 times sine of x plus 2. And this gives me a whole number, so sine of x plus 1 equals 0. Now we do the 0 product rule, and each part can equal 0. So I take 3 sine of x plus 2 is equal to 0. And I take sine of x plus 1 is equal to 0. All right, I'm going to speed things up a little bit to get the trig functions by itself. I will minus 2, and I'll divide by 3. So that gives me sine of x is equal to negative 2/3. Here, I'm going to minus 1, and I have sine of x is equal to negative 1. Now I can inverse sine both sides, and if I get a number that my calculator is nice, like 30, 45, or 60, or a quadrantal, I know I should have been able to do it in my head or without a calculator. But when you take inverse sine on both sides here, you actually get negative 42 degrees. Now that's not our final answer, but that shows that you did not have something, don't worry about the negative when you're thinking about triangles, but with an opposite side of 2 and a hypotenuse of 3. We didn't know that, so our calculator was needed for that. But if you remember, I said we want our answers in between 0 degrees and 360 degrees. Negative 42 is not in that realm, but if you draw it and think about the family member, you'll be able to figure everything out. So you guys, I'm going to take this right over here and describe it a little bit better. When you have negative 42 degrees, you travel down 42 degrees, but that's not the only way to get there. You could go from 0 in the positive rotation. So if you're 42 degrees short of 360, you're at 318 degrees is one of my final answers. So again, I'm not even going to box the negative 42 degrees. But the next thing I should know, again, is all students take classes. All students take classes. Well, where is sine going to give you a negative answer? Well, if it's positive here and here, it also is negative here. So I'm going to put the 42 degree reference angle in the third quadrant. 180 plus 42 is 222 degrees. So you guys, we don't need those T and C there by our answers, but those were our 2 final answers in between 0 and 360. Now, this one, whenever you type it in your calculator, you're going to get negative 90 degrees. And once you get that, you realize, oh, I should have been able to do it without my calculator. So if you know your quadrantals well enough, you could think about, well, what's the only time we ever saw 1 with sine is using that unit circle. And sine deals with the y value, And yep, the y value is -1. Now you might think, well, I can keep that answer. But again, you can't. It's not in between 0 and 360. So instead of calling this angle here -90 degrees, you could travel positive 270 degrees. And then you might think, well, he's been getting 2 answers for every single other problem. Like we got 2 answers here for this trig function. We have 2 answers in numbers 1 and 2. Well, this one you don't, because there's no other time where a quadrantal will give you a y of -1. So this is actually the only solution for that equation in between 0 and 360. All right, you guys, I hope this helped. Again, watch this video more than once, but you have to copy your own notes. Okay, so take out a sheet of paper, write this stuff down. And if you need anything, let me know in the comments. You guys can pause the video, re-watch the video, all that stuff until it actually makes sense, or send me a message and I will help you out. All right, you guys, here are your 3 homework examples that I expect you guys to do. So the homework for 4-6 is number 1, 4 times sine of x minus 7 equals 2 times sine of x minus 5. Number 2, 12 cosine of x plus 7 equals 9. And number 3, tangent squared x equals rad 3 times tangent of x. Now, here I'm going to give a little hint for number 3. The hint for number 3 is, in our 3 in our notes, we used MA, bottoms up factoring. There will be a factoring you have to use here after you get everything on one side, okay? So, when you move everything on one side, the hint is try greatest common factor. So all the same skills that we've used in our Algebra 1 class can be applied here by our factoring techniques. And please remember what tangent squared of x is. If we know sine squared of x is sine of x times sine of x, you have to know that that's really tangent of x times tangent of x. Hope that helps. All right, you guys, make sure again you copy the notes down. You do these problems because we'll have Google Forms where you just have to submit pictures, and that's how we're going to kind of do participation now on a daily basis. You might not do a Google form every day, but please make sure you're following along and let me know if you have questions. Miss you guys, and hopefully you're staying healthy and safe. Hopefully all your family members are healthy and safe as well. If you need anything, please feel free to reach out to me. All right, you guys. It's your boy, Mr. P.